Okay, in this video we're going to be talking about an application of a sum formula. In this case we're talking about the cosine of two things that are added together. That's cosine u plus v. So the first thing I'm going to do if I see a problem like this, when I'm told to write it as an algebraic expression, is I'm going to identify u as arctan of 1, and v is going to be then arc cosine of x. And really what this means is that if I've identified u, that means there's a triangle that exists. I'm just going to assume first quadrant because I don't know what quadrant it's in. But I'm going to then arctan of 1. If I get that, that means there's a triangle that exists with an angle u in the inside of that triangle. And it means that u has a tangent of 1. The tangent of u is 1. So that means opposite and adjacent are both 1. Well, this is nice because Pythagorean theorem will tell me that the third side is square root of 2, and we already know that triangle, don't we? Isn't that just 45 degrees? So really, this is 45 degrees. We could almost replace it if we wanted to. Okay. Second triangle. I'm going to look at it. I'm going to draw a triangle here. The angle inside of that is v. Now, according to this, according to angle v, it has a cosine of x, which means x over 1. In fact, we can write it like that if we want to, x over 1. But cosine is adjacent over hypotenuse. And now, if I use Pythagorean theorem, I'll find out that this is the square root of 1 minus x squared. So now I know the opposite side. So if I need to rewrite then cosine of u plus v, that means now I go through and I use my formula sheet, and of course at some point in time this needs to be memorized. For now we're practicing, so that's okay. And I see that cosine u plus v is going to involve the cosines and sines of both of these triangles. I'm going to take cosine u times cosine v minus sine u times sine v. Right? Okay. Cosine u, 1 over the square root of 2. I'm going to go ahead and write that as the square root of 2 over 2. I'm going to rationalize that denominator, right? That's the same thing as 1 over the square root of 2. Cosine v is x over 1 minus the sine of u, which is, once again, 1 over the square root of 2. I'm going to write that as the square root of 2 over 2 times the sine of v. And the sine of v, I can see in this case, is the square root of 1 minus x squared over 1. So I'm going to go ahead and I'm going to leave the denominator off this one. I'm going to leave the 1 off the bottom. But it turns out then that we have this expression. Now we just need to simplify. Well, it looks like I got the square root of 2 over 2 in both of them, so that helps me a little bit. But basically I have square root of 2 times x over 2, right? Minus the square root of 2 times the square root of 1 minus x squared all over 2. So I could do that. And then maybe I need to put them together. I don't know. There's really not. I mean, to do this, maybe we write it as one denominator. We put them both over 2, and we say x square root of 2 minus the square root of 2 times 1 minus x squared. We could do this. We could factor out maybe a square root of 2 if we wanted to. From here on out, it's really just how do you want to write the answer. There's not really a simple way to do it. But the idea is that we get something that looks like this in the end. That would be an okay answer. Let's do the same thing here. Kind of messy, right? That's going to be tough for you guys because you won't know when to stop, okay? But it's just really, if we can put it, simplify it as much as you can, okay? And we'll go from there. As long as I see this stuff, I'll probably be pretty happy because I know what you're doing. New problem. This time we're doing sine of two angles being added together. So it looks like maybe I want to start off here with identifying that u is going to be the arctangent of 1 and v is going to be the arc cosine of x. Looks pretty similar, doesn't it? In fact, it's the same triangle, except now we're doing sine u plus sine of u plus v, right? Arctan and arc cosine x, hey, those are the exact same thing. So I'm going to skip this step for now. All this stuff will come straight over here, right? We use the same exact triangles, but I need a new formula. The sine of u plus v, I see, is sine u cosine v plus cosine u sine v. Alright. Sine of u is 45 degrees, and sine of u is 1 over the square root of 2. I'm going to write that as the square root of 2 over 2. Cosine of v is going to be x over 1. Now, I need to add the cosine of u, which is 1 over the square root of 2. I'll write that as square root of 2 over 2. And I need the sine of v, which is the square root of 1 minus x squared over 1. Looks familiar, doesn't it? In fact, we see here that we have exactly the same thing, so my answer is going to be exactly the same as this, except it's going to have a plus sign in the middle, isn't it? And I've now written in sine of u plus v as an algebraic expression.